We're now in lesson 4.6, and I believe I'm going to break this up into two parts. So part one, today's focus is just going to be on this first objective. We're going to talk about factoring polynomials of using various methods. And then once we get the factoring down, that's going to help us with solving certain polynomial equations using factoring, but it's going to be important that we spend some time first on some possibly new types of factoring that you have not been exposed to previously. So let me give you some examples of what you're going to be doing on this assignment tonight. So for the first example I have, this is what we call factoring either the sum or the difference of two perfect cubes. And what I mean by two cubes, it's two terms that are being added or subtracted, and the thing about each of the terms is that they have perfect cube roots. And what I've given you here is a very important, if you want to call this a process, a definition, a pattern, this is the process that will be followed exactly to come up with the factoring of the sum of two cubes. You will follow this process, and if you have the difference of two perfect cubes, you will follow this second line. It's always important, as you can see here in my green statement, no matter what kind of factoring you're doing, you should always look for a GCF first. That should be the first thought that crosses your mind when you are doing any type of factoring. So with that said, let me give you some examples of factoring the sum or the difference of two perfect cubes. So letter A, first thing I'm going to do, as my green statement says, I'm going to look for a GCF, but I don't see one. And so now I'm going to follow this pattern that tells me how to take two perfect cube terms, they have perfect cube roots, and factor it in this way. Alright, so here we go. The cube root of x to the third is x. That will correspond to my letter A in this pattern that we're following. Since I'm subtracting in the binomial, the problem, then this first binomial factor should have minus as well. Now I'm going to do the cube root of 8, and that just means what number multiplied by itself 3 times. In other words, 2 to the third power, 2 times 2 times 2 is 8. And another way of saying that, the cube root of 8, the number that multiplies 3 times, is 2. So the cube root of 8 is 2, and the cube root of y to the third, of course, is just y. So the great thing about this factoring is once you've come up with these two terms identified as a and b, those two terms are used to create this trinomial that you see, this trinomial factor to the right. So just following my script, I'm going to take this first term of the binomial and square it. So x to the second power. My next sign is plus. This indicates that I need to take the two terms that I have in this binomial and multiply them together. And when I do that, I get 2xy. Follow that with a plus sign, and this tells me to take the second of these two terms, this b term, 2y, and square it. And when you take the product 2y and square it, it becomes 4y squared. And this represents the factoring of this difference between these two perfect cube terms. Okay, now let's try a sum of two cubes. So this time we're going to follow this top pattern. You see the plus sign here. It starts off the same way. We need to find the cube roots. The cube root of 64 is 4. 4 times 4 times 4 is 64. And then the cube root of a to the third is just a. Plus in the problem, so plus in the binomial. And the cube root of 1 is 1. Okay, and once again, I'm going to use these two terms. This would be the a term, and this would be considered the b term. And notice how we're going to come up with this trinomial factor to the right. So I take the first of these terms, 4a, and square it. That gives me 16a squared. Notice I'm going to follow that with a minus sign, so do exactly as it shows in this pattern. Now I'm going to multiply these together. 4a times 1 is 4a. And follow that with a plus sign. And now I'm going to square this last term. 1 squared is 1. And that is the factoring of this sum of two perfect cubes. All right. So moving on to some more examples. Here's letter C. Remember, it's so important that you train yourself to look for a GCF first. On the outset, you might be thinking, well, these are not two perfect cubes, so I can't employ that factoring method. But if you notice, there is a GCF here. 5 divides into both 5 and 320, and each of the terms have y in common. So when I factor out 5y as the GCF, I'm left with y cubed minus 64z cubed. And now in the parentheses, I do have the difference between two perfect cubes. So the factoring is going to look like this. Don't forget, 5y is still part of my factoring. Here, using the factoring method for the difference between two cubes, we need the cube roots. That'll be y minus, and the cube root of 64 again is 4. The cube root of z cubed is z. And then if you want to go back and look at your notes, remember we make this trinomial based on these terms. We square the first of these terms, plus we multiply these terms together. That's 4yz, plus, and then we square the last term, and that's 16z squared. And that ends up being the final factoring of this example, letter C. All right. Letter D, I notice the first term is a perfect cube term. 8 has a perfect cube root. Obviously y cubed does. But over here, although x cubed is a perfect cube variable, 5 is not. Since 5 doesn't have a perfect cube root, I can't use the factoring for the sum of two cubes. And since there is no GCF involved with these two, there is no factoring that can be done. And if factoring is not possible on any of your problems, you can just write prime. And that's the case for letter D. This is not factorable. Okay, so let's jump down to letter E and do the same thing. Let's see if we have a GCF. I noticed that 4 goes into 16, 8 also goes into 16, but it doesn't go into 54. So let's see what happens when we dividing 4 doesn't go into 54, so we're left with, since these are both even numbers, we can divide by 2. So let's see what happens when we divide 2 into both. And also notice that they have x in common, so 2x will be part of our GCF. So when we factor out GCF of 2x, we're going to get 8x cubed. And then over here, plus 2 goes into 54 27 times. The x's would cancel, and that gives me y to the third. So after factoring out the GCF of 2x, in the parentheses I have that sum of two cubes situation, and now we know how to factor that. So I'm going to bring down the factor 2x. I'm going to come up with the cube roots of each of these. The cube root of 8 again is 2. Cube root of x to the third is x, plus the cube root of 27 is 3. Cube root of y cubed is y. And now I make a trinomial from these two terms. So I square the first, that's 4x squared, minus, I multiply these together, 2 times 3 is 6, xy. And then I square this last term, and that gives me plus 9y squared. And that ends up being the factoring for letter E. Okay, so those are several examples of utilizing either the sum or the difference of two cubes, along with, of course, it's always true that you should check for a GCF before you do any type of factoring. Okay, so example number 2 is this method called factoring by grouping. And what this is all about, we're going to be dealing with polynomials. This is useful anytime you have polynomials of 4 or 6 or more terms, but in your assignment you're going to be dealing with polynomials with 6 terms. And here's the idea, and this takes a little practice, and the more you do it, the easier it becomes. You're going to try to come up with either 2 groups of 3 terms, or it also works if you do 3 groups of 2 terms. Now in your case it's going to be 2 groups of 3, and the thing about those 2 groups of 3 is the groups should have something in common. They should have a GCF among them. Let me show you what I mean here. If you survey this problem, all 6 terms, you should be picking out things, or what is it that certain terms have in common with each other. Like, for example, 7 and -56 and 112. It just so happens that all of those are divisible by the same number, and that number is 7. Okay, so with that in mind, let's take a look at the other 3 terms and see if they have something in common. So I'll just kind of color code so you can follow my process here. X to the third, negative x squared, positive 16x, they all have an x in common. So I'm going to group these together. I'm going to write them so that they are together. Okay, I've identified some commonality, and I'm setting up 2 groups of 3, and the groups are based on something that they have in common. So here's my green group. Okay, now let's go to the blue group and let's factor out that GCF that we said they had in common. That would be x. And the other factor would be x squared minus 8x plus 16. All right, jump over to the green group, and we said that right off the bat we noticed that 7 divides into each one of these numbers, so we're going to use 7 as the GCF, and now divide x squared minus 8x, and if you divide 7 into 112, that's 16. Well, do you notice that our parentheses match? And that is your signal. If you get the same terms in this case, the 2 sets of parentheses, you know you've done the correct factoring. And the answer will be, one of the factors will be the terms that are not in parentheses, x plus 7, times the matching or the common parentheses among both of these. So x squared minus 8x plus 16. And we would be done, but this trinomial, x squared minus 8x plus 16, is called a perfect square trinomial. And you can recognize those usually because the first and the last terms have perfect square roots. And when you take those square roots together, multiply together, and then double it, you will get the middle. And that's what qualifies this as a perfect square. So, perfect square trinomial. So they factor a certain way. So let me get to a final answer. X plus 7 doesn't factor, it's prime. But this trinomial, this perfect square trinomial, factors as x minus 4 quantities squared. Now you could have used the old-fashioned method of trying to figure out the factors of 16 that add up to -8, Well, you can probably see that that's -4 and -4, and so you could have written the answer as x minus 4 times x minus 4. You could have written it out twice, but I just wrote it out as x minus 4 quantity squared. Okay, and that is the answer for example A using the factoring by grouping method. Okay, letter B, and again, the more you do these, you'll pick up on patterns, you'll pick up on common things about these terms that will help you in the grouping process. Like, for example, do you notice how these numbers, these coefficients, are all divisible by the same number 6? So you can try putting those together as a group. And the other numbers that remain should have something in common. And they have x squared. You can divide x squared into each of them. So I'm going to write the blue terms. Here's the blue group. And then we'll do the green group. Now let's pull out that GCF out of the blue group, and that's x squared. So the other factor will be 2x squared minus 3x minus 5. And then jump over to the green group, and we said that they have 6. They're all divisible by 6. And when we factor out 6, we're going to get 2x squared minus 3x minus 5. So we're feeling pretty good because our parentheses, our trinomial in parentheses, match the blue and the green. And so we're going to put our answer as the part that's not in parentheses times the part that is. Now, x squared plus 6 is prime. You can't factor this. There's no GCF, no way to factor this at all. So that's one of my factors, but this trinomial does factor. So let's come over here, and I'm just going to write x squared plus 6 as part of my answer. But this trinomial can be factored as 2 linear. Remember, linear means x to the first. So if they're linear binomials, each one of them has to have x to the first in them. 2x times x is 2x squared. And now we need to put the factors of -5 in the second spots, but we got to be careful because we can't just put them anywhere. We need to make sure that when we put these factors of -5 in their place, when we do FOIL, we're going to get -3x in the middle. Okay, so you can think of as +1, that would give you +2x, and then if you put -5, now let's check this out with FOIL. We get 2x squared plus 2x outside minus 5x inside. If you put those together, you get -3x and then -5. So it checks out with FOIL, and so that ends up being the final answer, doing all the factoring that is possible. Okay, let's try some more. Here is letter C, and take a look across this and see if you can pick out some things that possibly could be in common. I'm noticing as far as coefficients, I'm noticing that these coefficients are all divisible by the same number. 8, 80, and 200 are all divisible by 8. So let's try those as a group. It might be that you try 2 groups of 3 and it doesn't work, and so you got to come up with some other way of grouping. But you will always know if you're correct if the terms in the parentheses match. Okay, so I got my blue group here. Now let's go with the green group. And they have something in common. -25y cubed minus x squared y cubed 10xy cubed. They all have y cubed in common in the other three, the green group. Okay, so let's do the factoring of the GCF. 8 obviously goes into each one of the numbers, and then we can also factor out x cubed. And when we divide, we're going to get x squared plus 10x, and 8 goes into 225 times. All right, so let's jump over here to the green group, and we're going to pull out negative y to the third. Okay, you can typically just bring the sign down, and now divide. If you divide into this, you're going to get 25. Dividing into the next term, you're going to get plus x squared, and dividing into this last term, you're going to get plus 10x. Now, even though they're not in the same order, they are the same terms. The blue group matches the green group. Okay, so let's go down and put the terms that are not in parentheses together and the terms that are in parentheses. Okay, so we're not really even close to being done because in this group I've got the difference between two perfect cubes. And here I've got a perfect square trinomial, so I need to factor both of these. So I think what I'm going to do is, to give myself a little bit of room, I'm just going to make a copy of this and go to the next slide. Bear with me just a second. And we'll erase this other example. And we'll come back to that one in just a little bit. All right. So we showed you earlier, one of the first things in this lesson is how to factor the difference between two cubes. And so that's what we need to do here. So cube roots are 2x minus y. And then we're going to build a trinomial from these. Square this first term. That's 4x squared. Plus, multiply these together. 2xy. Plus, square this. Y squared. Okay, that takes care of the factoring of this. Now let's factor this perfect square trinomial. Those are really nice and easy. It's the square root of the first term, square root of the last term, whatever the sign is in front of the linear term goes between them. If you needed to write this down as x plus 5 times x plus 5, that would be okay. But this ends up being our final answer for the factoring. For example, letter C. Okay, hopefully it's making sense. So let me back up, and you've already gotten the answer to letter C. Now let's work through letter D. And hopefully you can see that really we have two groups. We have an a squared group. This has a squared, and a squared. And then we have a b squared group. 3 terms that have a squared and 3 terms that have b squared in them. So that's going to help us setting up our two groups. Here's the blue group, the a squares. And then we'll write out the green group, the b squares. Okay, factor out the GCF from each group. So from the blue group, that's going to be a squared. And after the other factor will be g minus 3h plus 6f. And in the green group, just bring down this sign, minus, and this is going to be b squared. And when you factor that out, you're going to get 6f plus g minus 3h. So once again, they're not in the same order, but they are the same terms. Minus 3h, positive g, 6f in both. So the two terms that are not in parentheses, times the group, the matching parentheses. And I notice that for this binomial, this is the difference between two perfect squares. So this is an Algebra 1 topic. We have a certain way of factoring the difference between two squares. Maybe you can think of this as a separate example, but just more more familiar to you. Let me write that better. If I ask you to factor x squared minus 16, you would say x plus 4 times x minus 4. Well, in much the same way, these two perfect squares subtracted would factor as a plus b times a minus b. And this trinomial does not factor anymore. It becomes one of my factor answers. All right, there's your final answer for example letter D. Okay, and this is going to conclude the lesson because, again, I'm going to break this up into two parts. We'll save solving for tomorrow, part 2. But let me help you out when there's a combination of cubes and squares. Combining cubes and squares. On the outset of letter A, I don't see a way to factor this because I don't have any method for factoring the difference between two terms that are raised to the 6th power. But if I rewrite this in such a way that it shows the difference between two squares, remember that rule that says when one power is raised to another power, you multiply these together. So we just found another way of writing x to the 6th and y to the 6th. And the reason why this is good is because now we have a way of factoring. It relates back to what we just looked at in this example. The difference between two perfect squares factors as this. So once again, here's two perfect squares, and they factor as x cubed minus y cubed times x cubed plus y cubed. Okay, so now we're going to go back to the beginning of our lesson today, and we know how to factor out both of these. Okay, let's start with the minus. You write down the cube roots. That's pretty easy. X minus y. And now we're going to make a trinomial from these. That's x squared plus xy plus y squared. And now let's jump over and factor the sum of two cubes. X plus y. Now make your trinomial. X squared minus xy plus y squared. And that is our final answer. We can't do any more factoring from there. Okay, very good. For letter B, it's a little different. There is no way to factor the sum of two squares. That was our approach here because we can factor the difference between two squares, and that opened up other possibilities for us. But there is no factoring method for the sum of two squares. But I do have a factoring method for the sum of two cubes. So in this case, we're kind of going to turn it around from what we did above. This time I'm going to do a squared raised to the 3rd plus b squared raised to the 3rd. And now I'm going to utilize that factoring method that says the sum of two cubes. All right, and so I find the cube roots. The cube root of this first term is just a squared, and the cube root of the second term is b squared. Now we're going to make our binomial or trinomial from these two terms. So again, we square the first term. When you raise a squared to the second, it becomes a to the 4th minus, multiply these together, a squared, b squared, plus, and now you square the last term, and that becomes b to the 4th. And that is it. We can't do any other factoring from here, so that ends up being our final answer. So here, notice when we have subtraction, if you can rewrite using the difference between two squares, that's always a good process. For the sum, you're going to basically set it up as the sum of two cubes. Okay, and letter C. Looks like we're going to need to do some grouping first. I guess we should check for GCF, but looks like we're going to have to approach this by doing grouping and then see if we have a combination of cubes and squares. So remember factoring by grouping. Let's see, can we find out any commonality among these? For example, I notice y cubed, and y cubed. That's interesting. And all of these have just x's. So it looks like they're already set up for us. That doesn't always happen. They're already pretty much organized. So I'll just underline these in green. I won't rewrite this whole problem. So for the green group, we're going to factor out x cubed. And when we do, we get x squared plus 4x plus 4. And then for the red group, we're going to factor out y cubed. And when we do, we get x squared plus 4x plus 4. So we did the grouping correctly. So let's gather up the part that is not, the two terms that are not in parentheses, multiplied by the matching parentheses. And, oh boy, we've got the sum of two cubes, which can factor. We also have a perfect square trinomial, which can factor. So we're going to need some more space. Let's go to a new slide, x cubed plus y cubed. And this is x squared plus 4x plus 4. Okay, so let's remember how we factor the sum of two cubes, the cube roots. And then remember our pattern, x squared minus xy plus y squared. And then this factors, it's a perfect square trinomial, so x plus 2 quantity squared. There is no other factoring possible, so that ends up being our final factored answer. Okay, so that's a lot of factoring, and it's the factoring that in many cases will make solving very easy. So I think if you get this down, it's going to make part 2 quite a bit easier when it comes to solving polynomial equations. So I hope this helps. We'll tackle part 2 tomorrow. Work hard on this assignment and let me know if I can help.